Good day everyone, this is Group 3 and today we'll be discussing about earthquake hazards. So our discussion will circle mostly at defining what is an earthquake and what is the primary and secondary hazards of an earthquake. So what is an earthquake? An earthquake is the perceptible shaking of the surface of the earth. It's either tectonic or volcanic. So why does it happen? It happened as a result from a sudden release of energy in the Earth's crust that creates seismic waves. So where it occurs along the edges of oceanic and continental plates. So earthquake has parts. It has focus. Focus is the place of origin of an earthquake. And directly above it is the epicenter. So focus is below the ground within the earth, and epicenter is directly above the focus. So when energy is released at the focus, seismic waves travel outward from that point in all directions. There are different types of seismic waves, each one traveling at varying speeds and motions. It's these waves that you feel during an earthquake. Epicenter again point on the surface of the earth that is directly above the underground point where fault rupture commences, producing an earthquake. The effects of the earthquake may not be most severe in the vicinity of the epicenter.
For the second part of our presentation, we are going to talk about earthquake's primary hazard. But first, let us define the term earthquake hazards. So, earthquake hazards include any physical phenomenon associated with an earthquake that may produce adverse effects on human activities. With that being said, primary hazards are caused by the direct interaction of seismic wave energy with the ground. But in most situations, this is limited to fault rupture and ground shaking. So now let's proceed to the first primary hazard of an earthquake, which is ground shaking. Ground shaking is a term used to describe the vibration of the ground during an earthquake. It is mainly caused by body waves and surface waves. As a generalization, the severity of ground shaking increases as magnitude increases and decreases as distance from the causative fault increases. So basically, we can say that the severity of ground shaking is directly proportional to the magnitude, while the severity of ground shaking naman is indirectly proportional to the distance from the causative fault. So when a fault ruptures, seismic waves are propagated at all directions. This causes the ground to vibrate at frequencies ranging from 0.1 to 30 Hz. So buildings vibrate as a consequence of the ground shaking. Damage only takes place if the building cannot withstand these vibrations. Now, compressional waves and shear waves mainly cause high-frequency vibrations, which are more efficient than low-frequency waves in causing low buildings to vibrate. Now, when we say high-frequency vibrations, these are vibrations usually greater than 1 Hz. Now going to Rayleigh and Love waves. Rayleigh and Love waves mainly cause low frequency vibrations which are more efficient than high frequency waves in causing tall buildings to vibrate. Now, because amplitudes of low frequency vibrations decay less rapidly than high frequency vibrations as distance from the fault increases, tall buildings located at relatively great distances, usually 60 miles, from a fault are sometimes damaged. Now moving on to the second primary hazard of an earthquake, we have this what we call ground surface rupture. Now when we say surface rupture, it is the visible offset of the ground surface when an earthquake rupture along a fault affects the Earth's surface. Now surface rupture is opposed by buried rupture, where there is no displacement at ground level. This is a major risk to any structure that is built across a fault zone that may be active, in addition to any risk from ground shaking. Also, surface rupture entails vertical or horizontal movement on either side of a ruptured fault. Now, surface rupture can affect large areas of land. Moreover, surface ruptures commonly occur on pre-exhausting faults. Only rarely are earthquakes associated with faulting on entirely new fault structures. There is shallow hypocenter and large fracture energy on the asperities. The asperity is shallower than 5 kilometers. Examples of such earthquakes are San Fernando earthquake, Tabas earthquake in Iran, and Chichi earthquake in Taiwan. In surface rupture earthquakes, the large slips of land are concentrated in the shallow parts of the fault, and notably, permanent ground displacements which are measurable can be produced by shallow earthquakes of magnitude 5 or greater.
So now we move to the secondary hazards of the earthquake. During an earthquake, shaking is not all that happens. There are side effects that happens after the primary hazard has taken place. Some are even more dangerous than the earthquake itself. Secondary hazard can also affect neighboring countries of the country that experienced the earthquake. The secondary effects are the effects that occur directly as a result of the earthquake shaking and energy release. These are liquefaction, tsunami, landslides, and fires. First, liquefaction. Liquefaction occurs when vibrations or water pressure within a mass of soil cause the soil particles to lose contact with one another. As a result, the soil behaves like a liquid, has an inability to support weight, and can flow down very gentle slopes. This condition is usually temporary and is most often caused by an earthquake. Unstable soil. Loosely packed grains of soil are held together by friction. The pore spaces are filled with water, so the buildings and structures stand erect on stable soil. But when an earthquake occurs, shaking destabilizes the soil by increasing the space between the grains. With its structural loss, the soil flows like a liquid, causing the buildings and structures to tilt and sink as soil stability declines. Liquefaction and related phenomena have been responsible for tremendous amounts of damage in historical earthquakes around the world. Whether and where liquefaction will take place depends on many factors. These includes the loose granular sediment or fill, saturation by groundwater, and lastly, strong shaking. So the next secondary hazard is tsunami. A tsunami is a series of extremely long waves caused by a large and sudden displacement of the ocean, usually a result of an earthquake below or near the ocean floor. This force creates waves that radiate outward in all directions away from their source, sometimes crossing the entire ocean basins. Unlike the wind-driven waves, which only travel through the topmost layer of the ocean, tsunamis moves through the entire water column from the ocean floor to the ocean surface. So a tsunami only becomes hazardous when it approaches land. A tsunami can cause great loss of life and property damage in coastal areas. Very large tsunamis can cause damage to coastal regions thousands of miles away from the earthquake that caused them.
The other secondary effects are landslide and fire. A landslide is defined as the movement of a mass of rock, debris, or earth down a slope. Landslides are a type of mass wasting which denote any downslope movement of soil and rock under direct influence of gravity. It mostly occurs when an object is released from one's grip, it yields to the pull of gravity and must come down. Slope failures mostly happen when it changes from stable to unstable condition. The term landslide encompasses 5 modes of slope movement. First one is falls, a collapse of material from a cliff of steep slope. Topples, it occurs suddenly when a massive part of very steep slope breaks loose and rotate forward. Slides, it involves a large blocks of bedrock that break free and slide down along a planar or curved surface. Lateral spread, it is triggered by an earthquake and affecting gentle slope with less than 10 degrees inclination. And the last one is flows. It involves downslope motion of fine-grained clay, silt, and fine sand made mobile by the water saturation. These are further subdivided by the type of geologic material like bedrock, debris, or earth. Debris flows commonly referred to as mudflows or mudslides, and rock falls are example of common landslide types. Landslides are caused by this disturbance in the natural stability of a slope. They can accompany heavy rains or follow droughts, earthquakes, or volcanic eruptions. Mudslides develop when a water rapidly accumulates in the ground and result in a surge of water-saturated rock, earth, and debris. Mudslides are usually start on a steep slope and can be activated by natural disasters. Areas where wildfires or human modification of the land have destroyed vegetation on the slope are particularly more vulnerable to landslide during and after heavy rains. And what can a local government unit and national government agencies can help? They can help by developing and enforcing ordinance, creating emergency management programs, partnership with private sector, and establishing hazard maps. And the next secondary effect is fire. Fire is a result of earthquake shaking influencing electricity, gas, or fire sources to ignite in and around infrastructure that is in a shaking area. Fires are major source of damage after earthquakes. Ground rupture and leaky connection can easily rupture natural gas mains and water mains that are both contributing to ignition of fires and hindering the effort to control them. These fires can be started by broken gas lines and power lines, or tip over wood or coal stoves. This can be a serious problem, especially if the water lines that feed the fire hydrants are broken too. For example, after the Great San Francisco earthquake in 1906, the city burned for 3 days. Most of the city was destroyed, and 250,000 people were left homeless. And that's all. Thank you. I hope you learned something from our presentation.